Hello everyone, welcome to our channel. We are going to solve this thermodynamic questions of GATE 2011 in metallurgy. First question is, if two systems P and Q are in thermal equilibrium with a third system M, then P and Q will also be in thermal equilibrium with each other. This is following. First law of thermodynamics, second law of thermodynamics, third law of thermodynamics, or zeroth law of thermodynamics. Basically, this is one of the basic law, and initially it was not made a law. So what happens? Scientists realized that it is the basic law, so it should be written first. Since first law and second law was defined, so they put it as the zeroth law of thermodynamics. Okay, everyone. Next question. 1 mole of element P is mixed with 1 mole of element Q. The entropy of mixing at 0 Kelvin is. Okay. So guys, here it is asking you to find the entropy, right? So when these two elements are mixed like P and Q. Okay. So suppose P and Q are mixed. So it will have some entropy, right? So there will be two kinds of entropy basically. Thermal entropy and configurational entropy. Okay. Now since the temperature is 0 Kelvin, so at 0 Kelvin the thermal entropy vanishes. So we are only left with configuration entropy. And the formula for this configuration entropy is delta is equal to minus R XA ln XA plus XB ln XB, where A and B are elements. Suppose here two elements are there, so A and B. Now suppose there are three elements, then it will be like XC ln XC. Okay, like this. Okay, so these two elements are here, P and Q. And what is the number of mole of this? It is 1 mole and it is also 1 mole, right? So XA, A let us consider as P, right? So what will be the mole fraction of P? It will be 1 mole of P divided by 1 plus 1, right? Simple. So similarly it will be ln 1 divided by 2 plus XB will be 1 by 2 ln 1 by 2. No issue? Okay. So we'll write it right. So 1 by 1 plus 1, we can write it tightly as 1 by 2. Okay, so it will be ln 1 by 2, or we can write it as ln minus R ln 0.5. Okay, so option B. Next, zinc rod is immersed in dilute HCl. Okay, and this HCl is pure, right? If a very small amount of FeCl3 is added to the solution, the corrosion rate of zinc. Okay, so what happens with the corrosion rate of zinc, right? We have dilute HCl, so it will be in the form of H plus and Cl minus. Okay guys, no issue. Now since we have added also zinc, so what will happen, right? So zinc will form a product that is Zn2 plus, and it will give you 2 electron, right? So this electron will be taken by H plus and it will form H2. Okay, reaction will be like this, right? So this is the equation which happens, and the corrosion is happening over here. Now suppose I am adding a third element, that is FeCl3. So it will be like Fe3 plus Cl minus. Okay, now initially we had Cl minus and again we have this Cl minus, no issue. but you see there is Fe3 plus. That means it lacks electron, right? It lacks electron. That means it has a tendency to get some electrons. So from where only it can get? It will get by, again, the breakage of this. So if you more amount of this Zn2 plus will form, so this electron will move over here and the reaction will be like this. Okay, and further Fe2 plus 2 electron will form this Fe. Okay, then it will be like this. So more amount of electron is going to liberated, so this will be liberated from this Zn. Okay, so that's why the corrosion will increase. Okay, all of you understood this? Okay, now let us move to question 15. A metal is electrochemically polarized to a potential which is higher than the standard reduction potential of the metal. The over voltage will be, right? This is a very simple question. Over voltage is defined as the final voltage minus initial voltage. Okay, so here it is given a metal is electrochemically polarized to a potential which is higher than the standard. It is higher, so high minus than the equilibrium one, right, or the standard one. So high minus, you can consider like low, so it will be a positive value. Okay, it will be a positive one, so no problem. Option C. Let us move on. Aluminium is not commercially produced by carbothermic reduction primarily because, okay, it is not produced by carbothermic. Carbothermic means reduction using carbon, right? We have this Al2O3. Now suppose I make it react with carbon, then we can have equation like Al plus this CO2. Okay, so this is nothing but a carbothermic reduction of Al2O3. So why it doesn't happen? It doesn't happen because of this option D. Okay, you guys remember this, because if you see Al2O3 line is too low in the Laminar diagram and needs exceptionally high temperature. That means suppose this is your Laminar diagram where we draw delta G naught. Okay, and what is over here? Here is temperature. So what is the equation which holds over here? Delta H naught minus T delta H naught. Okay, now suppose this Al and Al2O3 line is very low. Okay, and guys, this CO1, this carbon reaction one which happens, okay, so what happens? The reaction is like this: C plus half O2 equal to Cl. So this is somewhat like this. Okay, okay, this is somewhat like this. So this defines the temperature, because since it is very lower, so this temperature goes very high. So once this temperature goes high, so it becomes very difficult, because above this temperature only this carbon will act as a reducing agent. Okay, okay, now if you look at this other options, aluminum metal will have excessive dissolved oxygen. There is no issue with this. It melts at too low a temperature. Okay, now this is not the perfect reason. It does not vaporize at reasonable temperature. So this A, B and C are not reasonable region, only D is the reasonable region. Okay, now question number 27. For a reaction A to B, if the rate of change in concentration of A that is Ca, can be written as minus dCa by dt is equal to kCa whole square, then the change in concentration with time from initial concentration of A, that is Ca naught, is given by, okay guys. So this is the equation, minus dCa by dt is equal to kCa whole square. So here it is asking that the change in concentration with time. So basically it is telling you that what is the final equation which we have, right? So how can we find this? So this is a more like a mathematical question, not this thermodynamics question. So let us rearrange this. We can write like this. Now do the integration. So initial concentration is Ca naught and the final concentration, let it be Ca, okay, and the time initial is here 0 and the final time is t. So this we can write. So it is like minus dCa by c square. So it is like minus dx by x square. So it will be like 1 by x. The the integration of minus 1 by x square is equal to 1 by x, okay. So 1 by Ca. So we'll put these values and it will be like k t 0 to t. So 1 by Ca minus 1 by Ca naught is equal to kT. Let us find which is the option. Yes, it matches with A. So clear? Okay. Now let us move. Okay. During fully developed laminar flow in a circular pipe, the velocity profile is parabolic and symmetric around the axis. The velocity at the tube wall is 0. The ratio of the average velocity to the maximum velocity is, okay. Now suppose this is your pipe, or you consider it a tube. So the velocity profile looks like this, okay. So in the middle this has the maximum velocity, that is u max, okay, and the average velocity, that is u average, is calculated by this velocity and it is divided by this complete area, okay, to find out this u average. So in the case of pipe, this u max by u average is equal to 2, okay. So here in the question it is asking velocity average by u max, so it will be 1 by 2, right? Now remember guys, if there is a parallel plate where the fluid passes through this parallel plate, right? So here also the velocity profile would look somewhat similar like this, but here this u max by u average will be equal to 3 by 2. That means it will be 1.5 times, the u max will be 1.5 times of your average. And in the case of pipe, this is your pipe, this is your plate. In the case of pipe, it will be 2 times of average. Fine, no problem. That will be option B. Let us proceed. If K is the rate constant for a reaction and T is the absolute temperature in the given figure, the activation energy for the reaction is, okay. So this is the diagram which has been given to you. If K is the rate constant, right? Guys, what is the equation for the rate constant? It is K is equal to A e to the power minus activation energy by RT. A is a constant, okay. Now if you look at this graph, then here the graph is between ln K and 1 by T, right? So to plot this graph, we will have to take ln in this equation, so it will be ln K equal to ln A minus E by R t, right? So this ln k and here 1 by t, right? So it is like y is equal to c plus mx, where m is your slope, so m is equal to minus e by r. Okay, right? So from here, by equating with a line equation, we need to find the activation energy. So this activation energy we can find, like suppose we find this m value, then we can find, like we'll multiply it with r with a negative sign, then it will give us this e value. Okay, so now let us find this slope, and since the slope is negative, so the answer will be incompletely positive. Okay, right? Now guys, if you see in the book, that Arihant book, so here it is written minus b over here, right? Here, this one, minus b over here, so it is actually minus 8. Okay, so you can correct this. Now, so let us find the slope. Slope, how we find? Like y2 minus y1 by x2 minus x1. So let us consider this x2 y2 and here x1 y1, right? So y2 minus y1, so y2, right? So this is your y-axis and this is your x-axis. Let us consider like this. So ln k over here, so y2 value is here minus 8 minus, and y1 value is minus 9, so it will be minus minus plus, so 9, and x2 minus x1, so x2 is 1 into 10 power minus 3 and minus here, so 2 into 10 power minus 3, so it is like 1 divided by minus 1 into 10 power minus 3, it will be minus 1000. Okay, so this is the slope. So now since we have the slope, so this will equate directly with this, equal to minus e by r. So e is equal to 8.314 into 1000, so it will be 8314. Okay, it is easy. Yes, it is easy. Okay, now let us proceed. The question number 32. 2 copper solid plus 0.5 O2 gas equal to CO2O solid. Delta G naught equal to minus 162200 plus 69.24 T joule. 2 copper liquid plus 0.5 O2 gas is equal to CO2O solid. Delta G naught equal to minus 188300 plus 88.48 T joule. The molar free energy change at 1300 Kelvin for the transformation of solid copper to liquid copper. Okay, so for this copper conversion, that is from solid to copper liquid, what is this free energy change, right? So if you calculate for similar for single change, like 1 mole of copper will give 1 mole of liquid, right? So now we have to bring this equation from this number 1 and number 2. So how can we bring, right? We can bring like, if you do like 1 minus 2, right? Equation 1 minus equation 2, then we can find it, because then O2 O2 will be cancel, then CO2 CO2 cancel, then we will get this, right? So let us do this. Okay, so it will be like 2CO solid plus 0.5 O2 gas is equal to CO2O solid, right? And here how will you write? Okay, this delta G naught will be whatever it is given over here, there will be no change of sign, but in the second case there will be changes, and because we are reversing the equation, it is 188300 minus 88.48 T. Now add this, it will be 2 copper solid is equal to to copper liquid. So delta G naught will be, you calculate it, but I am writing it directly because I have done the calculation already. So it is 26100 minus 19.24 into T. Okay, and what is the temperature? Here it is given, it is 1300 Kelvin, right? So let us find this delta G naught. 26100 minus 19.24 into 1300, so it is 1088, right? Okay, but here you see the molar free energy change, the transformation of solid copper to liquid copper. So here is also transformation, but it is of 2 mole. So why can't we just convert this 2 mole into single mole and we write the answer? So it will be copper solid equal to copper liquid. So this delta G naught by 2 it will be there, right? So it will be divided by 2, it will be 544. Answer will be in Joule. So this matches with option C. Okay, clear? Let us proceed. Question number 33. Al2O3 plus 6H plus 6 electron is equal to 3H2O plus 2A. Delta G naught equal to 897.3 kilojoule. Where hydrogen ion concentration is unity, the reduction potential of the above reaction under the standard state will be. Okay. Now guys, if you see in the Ariane book, they have written this delta G naught as with minus sign, but here it will be without any minus sign. So this is a correction, because if you find the real question, then there it is plus. Okay. Now this is the equation, right? So how many number of electron there is involvement? So n is equal to 6. Okay, and the hydrogen ion concentration is unity. Okay, so let us consider the reduction potential of the above reaction under standard state will be. So what will be the reduction potential? So now since delta G naught is given, so we will use this equation, delta G naught equal minus NF into E naught cell, right? So delta G naught is 897.3 into 1000 because it is kilojoule, minus N is 6, F is 96500, remember this, and E naught cell we have to find. This E naught cell will be equal to, just divide this. Okay, so let us divide, and if I divide this, then it will be minus 1.549, so that is equal to minus 1.55. So option A. Okay. So that means actually the reaction is happening in the different direction. Okay. Okay, no problem, but we have to find only this E naught cell. So we have found it is in minus 1.55. Let us proceed. Question number 34. G is equal to U plus PV minus TS. Then which one of the following is correct? Okay, so this is related to Maxwell equation. Okay. Now guys, for this type of problem, there are different approaches to solve. One approach is that you write down all the Maxwell equation, and from there you can easily do this and understand that how it has been used. Or if you look at the option, from there also you can predict what is the Maxwell equation which is being applied over here. See, in all equation we have this delta V by delta T, the first, right? See, in the second case, delta S by delta P. Okay, no issue. So that means we are differentiating volume and we are differentiating this entropy, right? So in which Maxwell equation this velocity and entropy both are present in a single form, that means that is in an absolute form, basically that is not in a differential form, right? So this is present in one equation, that is dg is equal to minus s dt plus v dp. See, v is present in a single form without any differential, and entropy is also present in single form, right? Now if you look at some other equation, other Maxwell equation, then only you can understand. Okay, so let us see. This is for dA. For dH we can write like tds plus vdp du is equal to tds minus pdp. Okay, now see here, this is your entropy and this is your volume, entropy and volume. Okay, entropy is without any differential, but volume is in differential, so this will not be the equation which will give you this answer. Then dH, t, so here ds is in differential, right? So this is also not going to solve your problem because here is also ds. Okay, so we are left with only option A, sorry, that means this equation. Okay, so how we proceed for this differential? We can proceed like minus delta s by delta we will have to differentiate with delta p, and there will be constant, the temperature will be equal to delta v by delta t by constant p. Okay, so this matches with the equation A or B. Yes, it matches with B. Okay, there is a minus sign. A and B looks similar, only there is minus sign over here. Okay, so it matches with equation B. Let us proceed. For the following reactions, the standard free energy change is given at 1773 Kelvin as follows. 2 by 3 Cr2O3 solid is equal to 4 by 3 Cr solid plus O2. Delta G naught equal to 447,800 joule. 2H2 gas plus O2 is equal to 2H2O gas. Delta G naught equal to minus 297,000 joule. If chromium oxide powder has to be reduced by hydrogen in a fluidized bed, the minimum pH2 by pH2O ratio that has to be maintained at the exit of the reactor is. Okay, so here if chromium oxide powder has to be reduced by hydrogen, so this Cr2O3 will have to react with hydrogen and form this chromium. Okay, that means we will have to add both equation. Okay, so let us add these two. First, let me write okay, this is what the equation it will give. Delta G naught will be equal to, let us sum this, it will be 150,800. Okay, so now this delta G naught we can write it as minus RT ln K. So it will be like minus RT ln here H2O whole square by H2 whole square. Yes, so it will be equal to minus, sorry, equal to 150,800. right? So it is what you have to calculate. Okay, so now I have done the calculation, so you do it like here. So PS2 by PS2 is equal to minus 5.11. Okay, this implies PS2 by PS2O ln will be equal to 5.11. So PS2 by PS2O will be equal to 10 to the power 5.11. It is equal to 166.51. Okay, option D. Let us move on. The hydrogen content of steel in equilibrium with hydrogen gas at 1 bar pressure is 28 ppm at some temperature. Hydrogen content in the metal at the same temperature gets reduced to 1 ppm when the equilibrium pH2 changes to, okay, right? So this is equation of nascent equation. So it is like 2H, right? So this molecular H2 breaks to form a nascent hydrogen and it gets dissolved, right? Now for this equation is weight percent of hydrogen is equal to some constant K root over Sp of H2 parcel pressure, right? So this gives you the concentration. So initially it is 28 ppm with parcel pressure of 1. And the next it is 1 ppm. So with parcel pressure of X, we don't know what is the parcel pressure, so we will divide both. So it will be 28 by 1 is equal to 1 by X. So this implies X is equal to 1 by 28 ka whole square. Okay, so it matches with option D. Now let us move. A furnace wall consists of two layers. The inside layer of 450 mm is made of lightweight bricks of thermal conductivity 1 watt per meter Kelvin, and the outside layer of 900 mm is made of refractory of thermal conductivity 2 watt per meter Kelvin. The hot face of the inside layer is at a temperature of 1300 Kelvin and the cold face of the outer layer is at 400 Kelvin. The temperature at the interface between the two layers is, okay, so there are two layers. One is this much and second is this much, because one it is 450 mm and the second it is double of this, that is 900 mm. Okay, now next thing we have is that the thermal conductivity is here 1 watt per meter Kelvin and here it is 2 watt per meter Kelvin. Okay, and this inside temperature is 1300 Kelvin and the outside temperature is 400 Kelvin. So there will be temperature drop something like this. So we have to find this middle temperature, that is Tm. Okay, now for this, what is the heat flow rate? The flow rate of heat, okay, it is Q is equal to 1300 minus Tm divided by L, that is length. Okay, so let be L by Ka. K is the thermal conductivity, A is the area. Okay, so for the first case, so this is will also be equal because the heat flow rate remains same. Okay, so it will be Tm minus 400 divided by L. So it will be, we can write it as L1 and here L2 to differentiate. So here we will write K1 and K2. A. because area is same, right? Area is same, so we can cut this one. So now we can write it as 1300 minus Tm. L is your 450. Let it be in mm only, no issue, because since both are written in same way, so it will be cancelled, unit will be cancelled. K, here it is 1, and here it is Tm minus 400, 900, it is 900 divided by 2. So see, 450 by 1 and 900 by 2, so both are same. So this implies 1300 plus 400 is equal to 2 times of T. This implies Tm is equal to 1700 by 2. So it is nothing but 850. And since temperature are given in Kelvin, so it will be 850 Kelvin. Okay guys, so this is it for this thermodynamics solution of GATE 2011. So some are very good questions and some are easy also. So hope you have enjoyed this, and